There is an old principle in warfare. Understanding the enemy goes far beyond merely observing them. One must grasp how they think, how they make decisions, how they fight, and, above all, why they employ specific tools. And it was precisely at this level that Ukraine began to operate. It did not merely study a Russian weapon. It decided to remake it in its own image, correcting flaws and amplifying its impact on the battlefield. What emerges from this is a story of accelerated adaptation, centering on the Molniya drone and its reimagined Ukrainian counterpart. The Molniya, whose name translates to lightning, is a fixed-wing kamikaze drone that Russia began deploying on a large scale starting in the spring of 2024. It was neither an impressive platform nor the product of advanced engineering. In practice, it was constructed from simple materials and assembled in improvised spaces that resembled ordinary workshops more than military facilities. The objective was never to innovate, but rather to simplify existing technology to the absolute limit. They integrated only the bare essentials in terms of electronics, just enough to ensure navigation and basic flight control. It was the most cost-effective method for delivering explosives via air to a target. And within the framework of this simple logic, the result proved effective, perhaps even more so than anticipated. Prior to the Molniya, the drone landscape in Ukraine was relatively predictable. On one side stood small FPV quadcopters, essentially racing drones repurposed to carry explosives, which were inexpensive and extremely lethal at short ranges. On the other were larger platforms, such as bombers capable of striking targets dozens of kilometers away while carrying heavier payloads. Yet even these specialized quadcopters remained relatively expensive and were reserved for high-value targets. For less critical objectives, long-range drones would come into play, utilized for strategic strikes deep within enemy territory. Each type fulfilled a specific role, defined by its own operational range and cost. However, one piece was still missing from this system. Neither side was utilizing, on a large scale, an inexpensive, medium-range, fixed-wing kamikaze drone capable of striking targets dozens of kilometers beyond the front line with a payload sufficient to damage significant objectives. This changed with the Molniya, which came to fill precisely this neglected niche, an intermediate zone where few options were truly effective. Artillery could not always reach these targets with precision, as deploying more advanced systems increased the risk of counterattacks. FPV drones, on the other hand, simply lacked sufficient range. To bridge this gap, Ukraine relied on short-range tactical missiles or more sophisticated drones, both of which were too expensive for large-scale deployment. However, the Molniya resolved this gap at a cost of between $300 and $800 per unit. In its most common configuration, it carries approximately 323 kilograms of explosives, flies at speeds of up to 96 kilometers per hour, and strikes targets located roughly 48 kilometers from its launch point. Its structure combines plywood, plastic, and aluminum tubing, while its electronics consist of common commercial components, largely sourced from China. A drone warfare expert went so far as to liken this simplicity and effectiveness to the AK-47 of the unmanned aircraft world. It does not impress with its engineering, but stands out for being simple, reliable, and easily mass-produced without the need for complex industrial infrastructure. The Molniya II introduced an innovation rarely seen in this category: twin propellers mounted on the wings, rather than the traditional single front-mounted propeller. This made it more stable when carrying payloads, improving control in windy conditions, and reducing the risk of catastrophic failure during flight. It also increased its versatility regarding the types of payloads it could carry. Confirmed payloads included standard fragmentation warheads, RPOA Schmel thermobaric warheads, and the TM-62 anti-tank mine, equivalent to approximately 7 kilograms of TNT, capable of leveling a building. The Molniya could strike a logistics hub located 40 kilometers behind the front lines, thereby keeping Russian soldiers out of harm's way. This combination of medium range, substantial payload capacity, and a cost of under $1,000 was hailed as the holy grail of drone warfare, leading Ukrainian analysts to cautiously assert that they had the situation under control. But that was not all. Its inexpensive and efficient design allowed for a wide margin of adaptation. Russia did not deploy a single standardized model, but rather utilized slightly different variants, all based on the same fundamental construction, yet branching out from there. Some models featured rear-mounted fiber optic control systems. While this limited their operational range, it rendered them impervious to electronic jamming. Other variants were equipped with thermal cameras for night vision, while some abandoned the kamikaze concept entirely. Instead of carrying solely an explosive payload, these Molniya variants were outfitted with HD cameras and gyroscopes, transmitting real-time imagery from the front lines. Assembly using distributed scrap materials allowed new units to be built with imported components, maintaining production even if a factory were hit. Ukraine not only copied the concept but also improved upon it. The original Molniya suffered from structural flaws, such as parts bonded with hot glue that would melt in the summer heat. Launching the drone required precise coordination among several individuals, as any error could prevent takeoff or cause the aircraft to crash. While this may seem like a minor detail, in combat, where the launch window lasts only 5 minutes, relying on the synchronized efforts of 4 people constitutes a serious vulnerability. The Blizgovka, whose name means lightning, resolved both of these limitations. Compromised parts were replaced with 3D printed components capable of withstanding wider temperature fluctuations and repeated use. The launch process was subsequently automated. Once flight parameters are configured, the drone takes off autonomously, thereby eliminating human coordination as a potential point of failure. Ukrainian engineers standardized connectors throughout the aircraft, facilitating maintenance and rapid field replacement. Communication systems were improved, and assembly procedures were adjusted to ensure greater consistency across units. The result was a drone costing approximately $810, one that is more reliable, boasts a longer range, and is easier to operate than the original model. The Blizgovka reaches speeds of up to 110 kilometers per hour, flies for 80 minutes, and attains an altitude of 2,000 meters. When paired with a repeater drone to boost the signal, it can strike targets up to 80 kilometers away, double the range of the Molniya. This solution eliminates the cost of satellite support for each mission. A small FPV drone positioned near the operational area relays the control signal, effectively doubling the operational range. The Blizgovka is a single-use platform, equipped with an internal warhead weighing approximately 89 kilograms, designed to strike the target directly. In contrast, systems such as the Jetmax carry either 2 heavy payloads or 8 smaller ones, allowing them to engage multiple types of targets without the need for specialized variants. By the time of the Defense Tech Valley Summit in the autumn of 2025, the Blizgovka was already deployed on the front lines. Vera drones simultaneously unveiled other platforms, the Sokil reconnaissance drones, now entering mass production, and the Jankoi UGV, an unmanned ground vehicle equipped with Starlink and capable of carrying over 450 kilograms. This demonstrates that the Blizgovka is part of a growing portfolio guided by a consistent philosophy: identify operational gaps, fill them cost-effectively, and deploy solutions rapidly. Nevertheless, the Blizgovka retains the inherent limitations of a fixed-wing aircraft. It is less agile than an FPV drone. It cannot hover, and, unlike a multirotor, it cannot abort a mission or reposition itself once launched. Strong winds make flight difficult, and dense fog can completely prevent takeoff. One operator noted that he invariably waits for the fog to clear before launching the drone. Against moving targets, or those that change position between launch and impact, a fixed-wing drone cannot maneuver like an FPV drone, which chases and adjusts its course immediately, moving in any direction without needing to point its fuselage forward. But this is where cost enters the equation. The heavy Nemesis drone, capable of hovering, repositioning, aborting an attack, and returning to base for rearming, costs tens of thousands of dollars per unit and requires a ground crew, a secure site, Starlink equipment, and 2 trained operators per shift. The Blizgovka costs far less. It can be prepared by 4 people in 10 minutes and launched from a field using a pneumatic catapult. The Blizgovka does not attempt to replicate the Nemesis. Instead, it assumes the role of artillery, striking targets at medium ranges more cheaply and precisely than conventional shells or volleys. In this context, the limitations of a fixed-wing design are acceptable. To understand Ukrainian advancements in drone warfare, one must view the system as a layered defense. Each layer combines route reconnaissance, fire teams, electronic warfare, engineering protection at critical points, and rigorous safety protocols. Jamming systems seek to disrupt radio control before Russian drones can reach their intended targets. The second, kinetic layer, involves small counter-drone combat teams equipped with adapted weapons and air defense gear. The third layer consists of physical barriers, such as the 40-kilometer netting tunnel along the Izium-Sloviansk road, designed to protect logistical routes. Anti-drone netting on vehicles positioned near command posts and movement corridors has become standard practice. Finally, interceptor drones, small quadcopters armed with explosives or fragmentation charges, complete the defense by shooting enemy drones out of the sky. To illustrate this point, Ukraine produced 100,000 interceptor drones by 2025 alone, with a combat success rate exceeding 60%. Each unit costs, on average, 25 times less than a Western air defense missile to hit the same target. What we see is a constantly evolving anti-drone ecosystem. Ukraine created something that larger armies failed to achieve: a layered anti-drone defense, operating in multiple domains, updated with field feedback and inexpensive to maintain. Russian advancements, such as Monia, fueled this development. With this, Russia ended up providing Ukraine with a defensive structure that can last beyond the war. At the same time, Ukraine expanded its offensive drone capabilities far beyond what Russia fielded, while maintaining comparable costs. Heavy bombers of the Nemesis Regiment, equipped with Starlink, operate hundreds of kilometers away. Medium-range attack drones carry warheads weighing over 90 kilograms, used against radars, air defenses, and aircraft. These are not close support weapons, but precision deep-sea assets, operated by remote teams. Such strategies are unprecedented in modern warfare. The Russian advantage has always been sacrificing human lives, advancing slowly with massed infantry. A drone war where operators are protected by Starlink practically eliminates this tool, as there is no way to threaten them or wear down their units from a distance. Ukraine is forming an army where dangerous tasks are performed by remotely controlled machines. At the end of 2025, they used a UGV, an unmanned ground vehicle armed with a machine gun, to hold a position for almost 6 weeks. Mikolas Inkovich summarized the strategy in 4 words: robots don't bleed. Blizgovka is not the first case. Ukraine observes, studies, reverse engineers, and quickly launches its own versions, as happened with the fiber-optic FPV drones used by Russia in the spring of 2024. On March 7, 2024, the Ukrainian press released images of a captured Russian fiber-optic FPV drone, which uses a thin spool of fiber-optic cable instead of radio, making it immune to electronic interference. Just 11 days later, on March 18, Dronaria, a Ukrainian drone development group, presented its functional prototype inspired by this captured equipment. In the technological game of large-scale warfare, Ukraine is often seen as more innovative, with motivated engineers and volunteers working in a flexible environment. When a Ukrainian solution proves effective, such as the basic FPV, Russia tends to copy and expand production or purchases. With fiber optics, Russia was a pioneer. Ukraine responded within 2 weeks with a functional prototype and began using operational versions within a few months. At the end of 2024, Chinese factories increased production due to Russian orders. The cost of reels fell from $1,500 in 2023 to around $500 per 10 kilometers in 2025, with complete drones costing $1,000 to $1,500. Both took advantage of the low prices. Russia purchased fiber directly, while Ukraine leveraged Western stockpiles or Chinese purchases. This allowed Russia to use fiber-optic drones immune to electronic jamming, reliably attacking targets and challenging Ukrainian operations. The cycle repeated itself with the Monia. Russia deploys, Ukraine captures. Engineers disassemble, detect flaws, and create improved versions. The Blizgovka remains on the front line, keeping the cycle active for Ukraine for a clear structural reason. Russian military development, even if voluntary and decentralized to some extent, goes through centralized command, requiring approvals, procurement processes, and institutional authorizations. In Ukraine, networks of volunteer engineers operate in a decentralized manner, receiving data from the front line and passing it on to manufacturers and designers. This structure allows systems to move from prototype to standardization and deployment much faster. If a Ukrainian engineer creates a hybrid fiber optic and radio drone with slightly higher costs and flaw correction, a manufacturer formalizes the design and produces a test batch. The system deploys prototypes on the front lines, monitors real-world performance, and decides on standardization or adjustments. This model surpasses traditional Russian and even Western methods by light years. This is because Ukraine cannot afford to wait. It does not have a population, industrial scale, projectile production, or tank reserves comparable to Russia's. It has an engineering culture capable of solving battlefield problems in days, not months. A flexible acquisition system rapidly transforms modifications from platoon engineers into official solutions within weeks. And an approach to drone warfare, refined over 4 years of combat, has created one of the most intensive uses of unmanned systems in military history. Above all, Ukraine understands that every minute counts. If Russia were to launch nuclear weapons, Ukraine would have no direct response. There is a limit to what drones can do, even with half the active military force. As long as the reactive development cycle lasts, Ukraine not only keeps pace with Russian innovation, but manages to maintain an advantage. Improving on a project that's already been tested is always faster than creating one from scratch. Today, Ukraine has mastered the art of taking what Russia leaves behind and returning it with greater force. Russia manufactured a cheap hammer. To keep up with the latest events in geopolitics and war, subscribe to the channel and activate the notification bell.